Hello again. As you can see, we're moving on to now the second part of the waves course for Nat 5. Previously, we had a little talk about what a wave actually is, how they behave, the fact that we can get different types of waves, sound waves, light waves, water waves. Then we talked about the two main categories of waves, longitudinal versus transverse. What we're going to do now is look at waves in general in a bit more detail, and as usual for physics, that means equations. We want to be thinking about how the waves actually behave, what properties of them we can work out mathematically. That's going to mean there's some new terms introduced, but most of what we cover in this video you should have already seen in S3, so it will hopefully be a little bit revision, a little bit new stuff. And so we'll manage fairly fine with it. And so we're going to start off then talking about frequency. That's the first of our new things for waves. Now, the frequency of a wave, as you can might guess, is how frequently it passes a point in 1 second. And we can calculate this if we know how many waves are produced in an amount of time. So imagine you're stood on the edge of a river and you're watching waves go by you. The frequency of those waves is just how many of those waves pass by you every second. So if you can count the waves, it's fairly easy to work out the frequency. And that gives us our first equation for today. And that is that frequency equals n over t, where f is the frequency, and that's measured in a new unit, hertz, Hz. N is simply the number of waves, so n doesn't have a unit because it's just a number. And then t is the time, and as always is measured in seconds. Remember, if you get a question with a time not in seconds, you must change it before you work it out. So let's look at an example of that. It's always the best way to learn the equation. So a wave machine at a water park produces 10 waves every minute. What is the frequency of a wave? So that's basically asking you, if you were in this water park, how many of those waves would you see pass by you every single second? Okay, so usual start, write down what we're after and what we know. So we don't know the frequency, we write that down. We know the number of waves and we know the time. Remembering 1 minute is equal to 60 seconds. Next step, as usual, write down the equation. Remembering there's always a mark for writing down the correct equation, so don't skip this step. You're throwing away marks if you do. Then we simply sub in. We put in 10 for the number, 60 for the time, do that calculation, and we get that the frequency is 0.167 Hertz. Okay, so you're not seeing a full wave pass you by every second because this is fairly slow. It's a low frequency. There's one thing you might notice about this answer, and that's to do with a video we had a couple of weeks ago, and that's that answer is given to 3 significant figures. If you put that in your calculator, you might actually get a much bigger answer, but we don't want all those numbers. Beyond a certain point, they're just in the way and annoying to write, but if we had too little, it's not accurate enough, and so we always go for 3 significant figures. Right, that's us discuss frequency. What links to that very, very closely is the idea of period. So the period of a wave is the time it takes one wave to pass a point. It can be simply calculated if you know the frequency. Very, very similar and very heavily linked. And that means that our equation for period is simply 1 divided by the frequency. And so we're here, big T here, big T is equal to the period. And like time, that is measured in seconds. And little f, just as before, is a frequency measured in hertz. Now, we're not going to look at a worked example of this. It's just 1 divided by the frequency. Okay, there's not much to see there. If you have a question where you don't know the frequency, you work that out using the equation we just did, pop that in, and that gives you the period. Remembering though that this equation, just like the one on the last page, we could make triangles for these in case we needed to rearrange them. So if we made a triangle for this one, it would say that the period here is equal to 1 divided by the frequency. So if you knew the period and were trying to work out the frequency, you could just cover up the frequency, and that would tell you that there'd be 1 over period. And if we made a little triangle for the equation we had on the last page, oh, that's a very badly drawn triangle, I do apologize. So frequency equals the number of waves divided by the time, and you could rearrange that similarly if you wanted to work out the number, but you need a frequency and time. Okay. Now, we've talked about frequency and period and learnt 2 little equations for that. What comes next in waves is really important. It's the big equation, one of the biggest equations and most important ones you'll do in physics, and one of the ones you'll use most often. And because it's so important, and physicists are terrible at naming things, we just call it a wave equation. Okay, nothing exciting, but at least it's easy to remember. So the speed of a wave, the frequency, and the wavelength of it. Remember, the wavelength is the distance between 2 peaks or 2 troughs. It's how long it takes the wave to repeat itself. They can all be related to each other using one formula. So that means if we know the speed and frequency, we can work out the wavelength. If we know the frequency and wavelength, we can work out the speed. Now remember, for most waves we're going to deal with, we're pretty much always going to know the speed. Because if it's a sound wave in air, we know that's 340 meters per second. If it's light in air, we know that's 3 times 10 to the 8 meters per second. If it's sound or light in other materials, that is given to you in your data sheet. So speed is normally one of the ones you're going to know, and you're going to then be instead working out the frequency or the wavelength. Let's have a look at the equation then. Our equation is V equals F lambda. You are given this, of course, like most of the equations, but you will use it so often you will never forget it. And in this equation, V is the speed of the wave, and as usual for speeds in physics, we measure that in meters per second. F is the frequency of the waves again, and lambda is the wavelength of the waves. Because this is a length, we measure it in meters. Now normally when we're dealing with waves, especially sound and light ones, the wavelength is going to be tiny. So you're going to see a lot of scientific notation when you're dealing with the wavelength of waves, because you're going to be looking at really small numbers. So be prepared for that. And again, if we wanted a triangle for these, hopefully I can do a better job than I did on the last one. We can pop ourselves a little triangle there and put in the thing. So V goes on the top, F here, and lambda there. That means then if we wanted to rearrange it, that would give us that F is equal to V over lambda. Oh, lambda's pretty hard to draw just with a mouse. And then that would also give us that lambda is equal to V over F. Right, so to finish off with today then, we'll look at a worked example of using the wave equation. Oops, sorry, I don't know what happened to the slide there. So yeah, we're trying to make things as clear as possible at all times. Right, that's us then seeing the 3 main equations for waves, 4 if you count the speed, distance, time one. The frequency one and the period one are important, they will come up. But the wave equation, that's the biggie. That's the one you're going to see all the time. So really make sure you're comfortable with that. But I'm sure you'll be happy to know there's going to be plenty of chances to practice that in the rest of the work best set this week. So again, thank you for listening.